Good afternoon, students. Today we are going to discuss about fluid mechanics. So, in this topic, we are going to discuss introduction to fluid, properties of fluid, problems on properties of fluid, and your types of fluid. So, first of all, what is fluid? Fluid is a substance that deforms continuously under the action of shear force. So fluid can deform continuously under shear force. It may be a liquid or may be a gas. So this is the definition of fluid. What is fluid mechanics? Now in this study or in fluid mechanics, we study the behavior of fluid which is at rest or in motion. In next slide, we are going to discuss about the properties of fluid. So what is the properties or what the properties that bears the fluid? So first of all, your density. Density, or it is also known as your mass density. It is defined by the symbol rho. Here is the symbol rho. Okay, 1 minute. So what is the definition of density? It is defined as the ratio of mass of the fluid divided by the volume of the fluid. So density is the ratio between mass of the fluid and volume of the fluid. Mathematically, density is equal to rho density, or the symbol is rho, equal to mass upon volume. Okay. So the unit of density is mass is the unit of mass is your kg and the unit of volume is your meter cube. So the density is the unit of density is your kg per meter cube. Okay, we have to remember the density of water. The density of water is your 1000 kg per meter cube. Okay, so in 1 meter cube volume, the water, the weight of the water or the mass of the water is your 1000 kg. Okay. Next properties of fluid is weight density, or it is it is the ratio between weight of the fluid to the volume of the fluid. In density or in mass density, it is the ratio between mass of the fluid divided by your volume of the fluid. But in case of your weight density, it is the ratio between your weight of the fluid to the volume of the fluid. Okay. So weight density, the symbol is your W. Weight density, the symbol is W. I told that what is the definition of the fluid divided by volume of the fluid. So again, the weight of the fluid is also defined by your mass of the fluid into acceleration due to gravity. Weight of the fluid can also be defined as your mass of the fluid into acceleration due to gravity, and the volume of the fluid is in denominator. So mass of the fluid into G divided by volume of the fluid. Mass per volume, in previous slide we have discussed that mass per volume is known as your density. So your weight density can also be defined as W equal to rho into G. You have to remember this formula, W equal to rho into G. Okay. Next one, your specific volume. So specific volume, the definition shows that it is defined as the volume of the fluid occupied by the unit mass or volume of the fluid. What is the definition say? Specific volume. The definition says that it is defined as the ratio between volume of the fluid occupied by unit mass or volume of the fluid. Okay. So specific volume, your specific volume is equal to volume of the fluid divided by mass of the fluid. It is the mathematically we can write like that. So here it also can be written that 1 divided by mass of the fluid divided by volume of the fluid. Volume of the fluid divided by mass of the fluid can also be written as 1 divided by mass of the fluid divided by volume of the fluid. Why you do like this? Now we know that mass of the fluid divided by volume of the fluid is known as your density. So your specific volume can also be written as 1 by rho. Okay. Next one is your specific gravity. Specific gravity, what is the definition? Now it is defined as the density of the fluid to the weight density of standard fluid. Specific gravity can be defined as the density of fluid divided by weight density of standard fluid. It is denoted by the letter S. Sorry. It is denoted by your letter S. So mathematically, what can we written the specific gravity? Mathematically, we can written as weight density of the liquid divided by weight density of water, or it is also weight density of standard fluid. Here we are taking standard fluid as water. That's why we are written as weight density of water here. Okay. So weight density of liquid. If I have written like that, S here, S equal to weight density of liquid divided by weight density of water. Here water is your standard fluid. Okay. So my equation becomes the weight density of liquid is equal to S into weight density of water. So S into weight density of water. So weight density of liquid equal to S into density of water. S into what is the density of water? 1000 kg per meter cube. So weight density of liquid by unknown liquid here, weight density of unknown liquid equal to specific gravity of the liquid into specific gravity of the liquid into density of water. Okay. Right. Okay. Let us discuss one problem. So the statements, the question said that calculate the specific weight, density and specific gravity of 1 liter of liquid which weight is 7 Newton. Sorry, weight is 7 Newton. So here the data given is your 1 liter of liquid, means your volume is 1 liter and the weight is your 7 Newton. These two things are given in the question. We have to determine what? We have to determine your specific gravity, specific weight, density, and second one is your specific gravity. Okay. So when we are going to derive your specific weight, we know the formula. What is specific weight? We have discussed in the previous slide. Specific weight is equal to, देखो, in previous slide we have already discussed your specific weight. Direct we have to put this formula. Specific weight, W is equal to weight of the fluid divided by volume of the fluid. We know this formula. So okay, so here we have to derive your specific weight. Specific weight equal to, we see the formula is weight of the fluid divided by volume of the fluid. So weight of fluid divided by volume of fluid. So in question we know that the weight of the fluid is your 7 Newton. So weight of the fluid is 7 Newton divided by, what is the volume of the fluid? Now sir, volume of the fluid is 1 liter. In 1 liter it can also be written as 1 by 1000 meter cube. 1 liter is equal to 1 by 1000 meter cube. So here in case of your volume of the fluid, we are written the what? 1 divided by 1000 meter cube. Okay, so specific weight is equal to 7 divided by 1 by 1000. So this can be become 7000 Newton per meter cube. Okay, so here we have derived specific weight. We know that the formula of specific weight is equal to weight of the fluid divided by volume of the fluid. In question it is given that the weight of the fluid is your 7 Newton. So we have written here the 7 Newton. The volume of the fluid is 1 liter. Here we are 1 liter means 1 by 1000 meter cube. So we are putting 1 by 1000 meter cube. So 7 divided by 1 by 1000 meter cube. So equal to, this is your 7000 Newton per meter cube. This is your specific weight. Okay. Next one is your density. Okay. So density is defined as mass upon volume. Here we are written it like density rho equal to W divided by G. Okay. One minute. This is your specific weight. Okay, or weight density. Weight density equal to, here we can written that weight density equal to W equal to rho into Z. This formula we have to use. This formula we have to use here in case of your density. W equal to rho into Z. Okay, so density equal to your W divided by G. This is known as your rho into Z divided by your G. Okay, so we know that what is the specific weight value here. So this is your 7000 divided by G is your 9.81. Okay, so what is the value? Now 7000 divided by 9.81 is equal to 713.55. Okay, obviously the unit is your kg per meter cube. Okay, so density of the liquid whose weight is 7 Newton is equal to 713.55 kg per meter cube. Okay, last one is your specific gravity. Okay, specific gravity is equal to specific gravity is equal to weight of unknown liquid or weight of liquid divided by, this is your specific gravity is your density of liquid. Specific gravity is your density of liquid divided by density of standard liquid. Specific gravity is your density of liquid or density of unknown liquid divided by density of standard liquid. So what is the density of unknown liquid? Now this is your 713.5 divided by density of standard liquid, we are taking standard liquid as your water, so density of standard liquid is your 1000. So this is your specific gravity is 0.7135. Okay, this is your specific gravity. So in problem, this is for this problem, this is your answer. We derive specific weight, density, or your specific gravity. Okay, let's come to the next slide. Types of fluid. In types of fluid, we have discussed about your ideal fluid, real fluid, Newtonian and non-Newtonian fluid. So in case of your ideal fluid, what is the definition say? The definition says that a ideal fluid is a incompressible fluid or it is an imaginary fluid. Okay, so ideal fluid not exist practically in surrounding. So a fluid which is incompressible and having no viscosity is known as your ideal fluid. It is an imaginary fluid not existing in nature. What is real fluid? The fluid which possesses viscosity is known as your real fluid. It is all the fluids in actual nature is known as your real fluid. Okay. Third one is your Newtonian fluid, a real fluid in which shear stress is directly proportional to the velocity gradient is known as your Newtonian fluid. So in case of a Newtonian fluid, it must be a real fluid in which the shear stress is directly proportional to the velocity gradient. Okay. Next one is your non-Newtonian fluid, a real fluid in which the shear stress is not proportional to your velocity gradient is known as your non-Newtonian fluid. Okay. Okay. Thank you. We are discussing in next slide. Thank you.